Okay, so welcome back to this live coding session where we code a HTTP server from scratch using C. And yesterday we actually left off with finishing the SQLite server connection to be able to store some email addresses in a SQLite 3 database. Today we're going to look at asynchrony and especially connection management, because at the moment we can only have one connection per thread the whole time, which might not be what we want, because if somebody actually holds on to a connection for a very long time, then our server will stall for the entire time that the client is holding on to that connection. So we want to, one, have multiple connections per thread and read on the connections that have actually data available. And two, we want to create timers that tell our application to expire connections and close them. Okay, so let's look into this. The things we probably want to use is epoll, the syscall epoll, and a timer FD. So epoll for polling, for actually polling on the available file descriptors. So epoll will tell us which file descriptors are ready to read, and actually a timer file descriptor that we can use to put it in our epoll and delete connections if necessary. I read through this and I have never really used it before. We will probably look at the example and try to create something that is somewhat similar. So I think we need something like sys epoll here, and where we actually want to integrate this is so in here we say accept so initially we probably only want an epoll with set non-blocking. While usage is a nice non-blocking socket. We probably want to make this a level triggered thing. And I didn't quite get the difference between level triggered and edge triggered. So edge triggered delivers events only when changes occur on the monitored file. So when we read but not the entire thing, then it would block the entire time because it doesn't update. So we have to make the socket so epoll event triggered or level triggered. I mean, it's about having it blocking or not. Events can be generated upon to disable the associated file descriptor after receipt of an event. Okay. One shot. So one shot would be something like the timer. Maybe we start with making this level triggered and having blocking things. So initially we need to create an epoll. This is probably the first step. So I wonder why there is a create one. If flags 0, why are there 2? Creates a new epoll instance. If flags is 0, then other than the fact that the obsolete size argument is dropped, is the same as epoll create, and they did it with 0. Okay. So I think we just make epoll create. Okay, on success, returns a file descriptor. So epoll fd. And if the epoll fd is equal to -1, then we return null. Okay. Good. After creating, we can also say exit. Okay. Epoll in. So ev. Okay, so we have some events. So struct events. No, it's epoll event. Events, max events. Let's define that later, and then we can do that as well. Okay. Okay, the socket descriptor is something we already have. And event. So an epoll event. Okay. Use. Okay, first so where's the documentation for the epoll? So we do something like events epoll in. Epoll event. Epoll event. Okay. Events and data. And epoll event. So events and data. Specified. Okay. And which one can I specify here? Epoll control. It's described in here. Yeah, but hello, which event poll epoll event event values. Man, what can I actually specify in here? Epoll in. Once by specifying epoll in. Epoll in, epoll out, epoll in, epoll out. Event types are epoll in. Available for write, okay. Good. Okay, so that's actually here. Bit mask. Okay. So we said ev dot what was it? Events epoll in and ev dot data dot file descriptor is equal to the socket descriptor. Okay. Now we probably want to epoll control okay. So epoll control and epoll file descriptor, the operation which is epoll control add, the ev, so this is probably something they did down here as well. Yeah, epoch control. And if this is equal to -1, fprintf no log cannot create epoll probably want to fail here. Assert not. Not cannot create add socket server socket to epoll. Okay. Good. So received invalid okay. So in here we want to use the epoll. So events nfds. So it probably puts it in the first n. Okay. And do we have to remove this? Full control. So how does it, so epoll, how does it remove it from the list? So can be generated upon receipt of multiple chunks of data. The caller has the option to specify the associated file descriptor after receipt of an event. When the epoll one-shot flag is specified, it's the caller's responsibility to rearm the file descriptor. Okay. Plugging the calling thread. Okay. So epoll wait. We have to call that on the epoll fd. So let's read the man page maybe. Epoll wait. The events, max events, and the timeout. Okay. To block indefinitely. Okay. Okay, so epoll wait. with our events, then the max events probably, and -1 so that it blocks indefinitely. This returns an int. Okay. So I32 NFDS is equal to this. For int I is equal to 0, I is less than NFDS plus I. And now we want to get the event. ev.events epoll event triggered. Okay. Okay, so if this if events n, no, they call it n, so let's if events I dot fd dot data dot fd is equal to socket descriptor do use fd. So if it's the socket descriptor, then we want to accept cfd okay. Then we want to say ev.data.fd is equal to cfd and ev.events. So when only after all the file descriptors. A file descriptor, what? So 1 second. The caller might end up waiting for some data that's already present inside the input buffer, and because of might block indefinitely. Employees should use non-blocking file descriptors to avoid having a blocking read or write star of a task. Non-blocking file descriptors by waiting for an event only after read write return E again. File descriptor refers to a file other than a socket and has been marked non-blocking, and the read would block. We're waiting for an event only after. Okay, I think, but we don't need to use. We don't need to use that actually. So ev dot events equal to epoll in, and now we want to add it again. Add so it didn't consume the entire thing, and then didn't change, just block indefinitely. Okay. So cannot add client socket to epoll. Good. So we add this. If this is equal to -1, blah 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 blah. Okay. So at this point, we also want to. Okay, so let's say else. This is a client file descriptor, and we want to read from it. Oh no. I'm not sure how much of it actually has to go in here, but I think it has to be all. Okay. I'm unsure if that's actually correct what we do here. Okay. So else. So this is maybe, let's say, I32 FD and FDS. FD is equal to events I data.fd. if this is the socket descriptor, maybe call this server socket. Server socket. Else create a new thing. I mean, this thing can be here as well. Red bytes. Request buffer. Something that could be pulled up. Init the writer. I think we only have to do that once. Let's see. And remaining and okay. Maybe we have to do that every time. Now I don't know where we did that. So we have some request buffer, and I think we also have, yeah, so, but that's part of the writer. So this is the file descriptor. This is the file descriptor. So after this, we cleared the whole thing. So probably something like reset. Ooh, no. Also file descriptor. Also file descriptor. And here, close file descriptor. Don't know what this is for. And I don't. Oh. So this didn't have a purpose. So we have this else, and then another one. Okay, I'm starting to lose sight of what I'm doing actually. Okay, so we have this epoll and we should be able to now read from this. I am actually quite unsure whether this now works. N in here. Broken handle. Okay. Let's see if it actually builds. I doubt that. Okay, so epoll. Client. So we still have this here. This is the file descriptor. Client socket descriptor. This is now the file descriptor. Client socket descriptor. Okay. Sock read. Declared here. So there's still one at 546. Shouldn't exist anymore. Clang. Okay. So epoll. Okay. Except. We can use file descriptor. And now epoll. Epoll control. Sys epoll.h. Okay. Requires 4 arguments. A file descriptor? What? And FD. Ooh. Wait, what? Control. Epoll control. So this wants the server socket. Okay. And in here, it also wants the other socket, which is the CFD. Okay, now bound define max events. I don't know. I don't know how many. 10? I have no idea. Okay, so now this compiles. Okay, so I guess this works. So, oh, I killed it. So if I now have a stalling connection, so netcat localhost 8080. So this is now something that nice. Okay, so this is nice. Not that hard, actually. Okay, so this works. Now we also want timers. Okay. So whenever we create a new client, we also want to create a new timer. So timer fd create. I wonder what it takes. So this creates a clock. This takes a clock ID and flags. So clock ID settail. So that the clock ID argument specifies the clock that is used to mark the progress of the timer. I wonder which one I should use. It must be one of the following. Which clock for Unix timer, for Linux timer. Which clock ID to choose for Linux timer? Wonder which one we should use. Get CPU clock ID or get CPU clock ID. Get CPU clock ID. Okay, maybe we just use this here. So pound include time.h, and in handle requests we want to get the clock. So this is probably something we do up here. So i32 clock ID is equal to clock get CPU clock ID. So the process ID, I wonder how we get that. Whose ID is PID. So this is clock ID, and now we also need the PID. So if this is not equal to 0, assert unable to get clock ID for the process. I mean, this is also something that is process-wide, so we can provide this here. So i32 clock ID is equal to handle requests args clock ID. So i32 clock ID. So we do this here, down at serve. So let's get the clock ID. I don't know where we do this. Bind, listen. Maybe just do it in here. Clock. Clock I32, clock ID. Put in the clock ID, and then we also need to get process ID Linux. Man. Get PID. Okay, so I32, so PID, clock ID, PID, T PID is equal to get PID. Can this return error? These functions are always successful, so this is just get PID. Okay, and then we provide this clock ID here. Okay. And up at handle requests, we get the clock ID. Then in here, where we want to create the timer, not timer create, but timer FD create. So clock ID and some flags. Non-block. The following values may be bitwise. Set the close on exec flag on the new file descriptor. Clo exec in open. Clo exec. Described below can be used to change this default. Specifying this flag permits a program to avoid additional versions to set the note that the use of this flag is essential in some multi-thread because using a separate version on this flag does not. So to avoid race conditions where one thread opens a file descriptor and attempts to set its close on exec flag depending on the order of execution. Yeah, I don't think we need this, so just 0. So if unable to create timer for connection. Okay, we create a timer. So I32, let's do something like timer FD. timer fd is equal to this, and if the timer fd is equal to -1, we cannot create it. And we also want to, where's p? We also want to put this one onto the epoll. So timer fd this is now the timer fd. I wonder why you have to put ev into this. Epoll event. The event arguments describe the object linked to the file descriptor. Described in. Okay, I see. This is something the kernel should save and return us back. Okay, so now we have to actually have a list of connections. So we have to make sure that, I mean, this can now either be a timer or a socket. So I wonder if ev can have additional data. So man event epoll event. So data can be an int or a pointer. It can also be a pointer. A file descriptor. So now we don't have a notion of whether this actually is a timer or something we can read from. So we could have a list of timer file descriptors. Get type of file descriptor. And see. Nope. Okay, so we want to create the timer and we also want to set, so we put it in here and we also want to set the timer, the time, so set time, timer fd set time, or what is it called? Timer set time. They provide an to the use of set iTimer. So timer set time. Arms or disarms the timer identified by timer ID. But oh no, timer fd set time. So if timer fd set time, timer fd, and some flags, which is timer. What What are the flags? Timer, apps time info, new value dot it value as an absolute value on the timer's clock. This flag is specified along the timer. Okay, we just 0. And iTimer spec new value. Okay. So we need a struct iTimer spec timer value. iTimer spec and its interval in seconds. Initial expiration. Interval for periodic timer. Specifies a non-zero value, then arms, setting it to initially expire at the given time. The timer was then the timer is disarmed. The new value field specifies the period of the timer in seconds and nanoseconds. In seconds and nanoseconds. If this field is non-zero, then each time that an armed timer expires, the timer is reloaded from the value specified in IT interval. If this field is non-zero of the timer, the period, so this is something, so this should be 0, I guess. So timer value 0 and where was this? 0 and so how does it know whether by default relative to the current time, this can be I wonder if it's now seconds or nanoseconds. Or timer with nanosecond precision. In seconds and nanoseconds. I don't really understand how that should work. So let's make it 30. So something like expiration, sex, maybe 5 for now. Or 4, I don't know. Expiration or expiration time. Expiration time. So give it this, how did I call it? Timer value. What? New value, old value. Specifies the initial expiration. New value. What is it doing with the old value argument is not null. The time of the call, so just null. I mean, we could also we could say we have initialized some timers first and then arm them. I mean, we need some association of the close socket after timeout. I wonder if there's yeah, so now we would need some way of I mean, we could say that EV data now becomes a pointer. So we could do something like, for this thing, we don't have to create them all over. We don't have to create them all the time. To do, maybe create the timers ahead of time and restrict the amount of concurrent connections. And what we could now do is, because we have some request local memory, we could allocate these we would also have to free them. I don't like this. So this can have a file descriptor, a pointer, uint32 and uint64. I mean, it would be nice if we so what if we actually do this? So we say something like connection client connections max connections, and this thing is defined as connection is a i32 CFD and a i32 timer FD TFD. So if this is a server socket, so we have n connections right now, n connections, n cons. If n cons is equal to so do we just reject it, or is it equal to max connection, max cons? So at this moment we can't accept new ones, but I mean, this would invalidate this epoll, wouldn't it? We probably would have to arm it again. Because it was ready. So this is a problem when you don't really understand how it's working. Auto sleep example, suggested usage. An event-driven state machine application should, after having received E again, record its current state so that the next call to do use FD will continue to read from where it stopped before. Okay. So this is now the question when we don't accept will it stay in here? I don't know. We will see. Log unable to receive more concurrent connections. Max connections exceeded. Okay. So if this is the case, we continue and okay. So now at this point, we say we do this here. So we create all the timers for and I is equal to 0, I is less than max cons plus I. we set this here. And we set client connections at I.tfd is equal to this. Oh, maybe do it like this. If no connections client, man, I can't type I.tfd is equal to timer fd. Okay, we initialize these, and in here we say, so we arm this guy. So what was it? It was a dot pointer, and this is the current connection. So client connections at ncons -1. And so let's say the current connection connection star next con is equal to client connections plus I, no, plus n cons. Then we say next con dot cfd is equal to cfd, and tfd is equal to the tfd we don't have to set. We set this to next con. With the timer fd with next con dot tfd, and then we arm the timer with a timer value. So this is next con tfd with a timer value, and if this is equal to -1, cannot arm timer for connection or what we could do. So this is this doesn't solve our problem. We don't know which one it is. Connection fd connection event, and this is the read cfd and struct connection event timer socket connection socket and timer. This can have these. And now a connection. So maybe this is struct this connection event. And this has a union of this. Which is just called data. Where was that? We call this a con event, and this has a con data. This is the con data. Now we're just so this is I32 a con socket or a struct con timer with the CFD and the TFD. Okay. And it has a tag, con tag. Con tag. This can either be a socket and con timer. Okay. So now we have that. Now that we have that out of the way, we'd say this is a con. What do we call it? Con event. Con event. Connection. Con events. So we create a timer. Okay, so this is probably not very correct. And let's say struct con timer is equal to this. Is this here, paste. And this is a con timer. And for all of these we have timers. So let's say we have con timer, con timers, and we say con timers dot this is equal to, let's call it TFT as well. Okay, TFT, blah, 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 blah. And down here, so we make this a, no. So this can store pointer. So maybe we don't do this, and let's say we just have like this, and in here we create but I don't like this. I don't like this. We don't know how many events we have, so but maybe this is also just 2 times that. I don't know. Actually, a little unsure of how we do this. We have to know whether it's a timer or not. And if it's a timer, it probably needs the client descriptor as well. And cons is equal to max cons. Okay. So in here, we need to say con events, con event is equal to you're trying to access the file descriptor here. Anyway, so there is no, we can't do this. No. Okay. Timer TFDs And we could reuse them, but I mean, we need some way of associating the timer with the client descriptor. We could also make a new epoll. I don't like that. Yeah. No, it was timer fd create. We need some way of saying this timer is for this connection. So we probably need some way of saying this is a struct con, and it has a connection client file descriptor and a timer file descriptor. And we have max con of these, so cons, and so max connects, max cons. And we can also, we could set the timers we have, so for int I 0 I is less than max cons plus plus I. Timer, so cons at I dot tfd is equal to create timer clock ID and null 0 if tfd is equal to -1, assert unable cannot create timer for connection, and cons at I dot tfd is equal to tfd. So we initialize these, and so we don't have to do this here. We can just say we say con as equal to cons at and cons, and say con cfd is equal to cfd, or maybe in here tfd is equal to tfd. No, that doesn't work. is equal to C TFD cons at I dot TFD cons at I dot TFD, and we say cons at I dot CFD is equal to CFD. Here also say I32 TFD is equal to cons at I dot TFD 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 TFD. Okay. So now we have to check whether this is a client file descriptor or a timer. FD type, get FD type, and FD. Cons and if this is equal to confd, else, so when is this a timer? Conc, also give me this. Else. So if this is a con, then we do this here. So if this is a connection, shit, wrong. So if this is a connection, we do this here. Oh my goodness. Why does it break all my indentation? Oh no. Close client socket. Else. So this we probably don't want to do. But we have to reset some things here, like these. close client socket. Clean request. Cleanup. Request cleanup. So go to request cleanup. So we don't close this. Don't need this break. Go to request cleanup. Oh. If we could not write this thing. So if we are unable, we go to close client socket. I don't like this. I don't like this right now. Okay, this should be indented. This seems like a lot of indentation here. Yeah. So this should probably be something, be a method where you could say, okay, reset this. So yeah. So this should just close the client file descriptor. Of course, if an error occurs here, then we can also close this. So it would be something like close No, this shouldn't close the connection. This should. So this shouldn't close the connection. This should. This shouldn't close connection. It should. It should reset the cleanup request, something like that. Clean all of this, but it shouldn't close it. So clean up request. Writer, header, map, I don't know. Request response. A request dot header map response dot header map. What else? The writer, we already had that. And the request local memory. Okay. So cleanup request and return. No, not return. Continue, probably. Continue. Close connection. So this cleanup could happen down here, regardless. So we could say this is somehow the cleanup. So request cleanup. And this is not part of it. This is a separate function that is called i32 close connection SSL. If TLS, then this is this. SSL star SSL i32 FD. Pound define close connection. Else pound define close connection okay, so so if we cannot close this, then we say, or cannot write, we say close connection and SSL c.cfd and request cleanup. Same thing for this. Close the connection. Same thing for this. Close connection. Go to request cleanup. Same thing here. Go to request cleanup. Go to request cleanup. Request clean. So this is something where we say close connection SSL c.cfd. So close connection. Request clean up. Cannot acquire this. So this is not set. We just say close FD and go to the request cleanup. I mean, we didn't really acquire anything, just to make sure. So if we actually got a timer here, we just close it off. Now we have to only implement the getFD type. So this is an enum fd timer and NFD type. This gets the file descriptor, the cons, and the result argument, which is a result, I guess. We go for int I is equal to 0, I is less than max cons plus plus I. And plus plus cons if star if cons and cons if cons CFD is equal to FD. Return, so star result is equal to cons, and return con, else if cons TFD is equal to FD, star result is equal to cons, return timer. Okay. And we can also not found. This should not happen actually. Assert not found. Okay. Else if it's more like a switch. I mean, this should not happen. This should never happen. Assert cannot find FD in cons. Okay. So this becomes just an else again, and I have no idea if this compiles. Close client connection. Confd, max cons. You know what? matching function call for get fd type, get fd type. Okay, and cons. And cons. We don't have and cons right now. And cons. Plus plus and cons. Now matching function call to get conversion from con16 to int star. What? Int star? Why int star? Where did I define the cont? Not the con, the con, oh here. Has empty body, timer, fd, set time. Timer spec with an L value of type. What the fuck? Use of undeclared identifier, create timer, timer fd create. Cannot initialize return object of type. I mean, we could also make this a linked list. Okay, not found was actually. Timer fd. Timer spec. Timer spec. And time.h. That is itemer spec. Itemer spec. Timer spec. Dereference argument with star. Result. Get fd type. Cannot dereference. What? Okay, so this compiles, but that means nothing. Cannot create timer. I think we leave it like this for now and fix all the bugs tomorrow. Thank you for watching. See you then.